And thank you everybody for showing up. I know we're kind of in the, 3/4 of the event, post-lunch kind of lull where you're kind of deciding whether or not you should go back and pack or whether you should still attend sessions. So appreciate you for all still showing up. In this session, as Shirley introduced me, we are going to be talking about immutable infrastructure through the usage of Terraform, Terraform Cloud, Packer, and HCP Packer. If I were to put this session into a nutshell, think about everything that we talked about this morning during the keynote. I'm going to be doing the demo version of that. So let's start rolling. A little bit about myself. I run our technical product marketing group that covers all of our products. My name is Kyle Ruddy. The easiest way to reach me is probably on Twitter. However, you can pretty much find me at KM Ruddy, across the board, GitHub, LinkedIn, and everything else. All right, so a little bit about the agenda. We're gonna start off with some updates to Terraform Core. We've had a couple releases this year already, and then we're going to dive into how we can use some of those updates with Terraform Cloud. And then again, most of this session is going to be demo-based, and we'll wrap up with an area where you can find some more information. All right, kicking off, Terraform Core. We, again, have had a couple updates this year. First and foremost was Terraform 1.2. This came out right around the HashiCorp EU over in Amsterdam. And what this did was introduce this notion of pre and post conditions. So basically, this allows you to build on top of a testing style of framework and add it directly into your Terraform configurations. So think about this as being able to create a resource and then validate something with that resource or within your entire configuration is as it should be. And if it's not, it actually stops the run. So you don't have to wait until it gets to the end of perhaps a long running configuration or anything along those lines. You have that immediate contextual awareness, especially through the custom error message. So right here we're checking to see if our public DNS has been set, and we can provide the error message of, hey, EC2 instance must be in a VPC that has public DNS host names enabled. So instantly you have that type of information available to you. This is also going to be very important when we get into the Terraform Cloud section, so keep that in your mind. Then we get into Terraform 1.3. This was released just a few weeks ago. This improves something that actually was released as part of Terraform 1.1 in the form of the moved block. So what the move block does is allow you to codify a way that you can move resources from, say, your root module into a separate local module. This really helps with the refactoring, and for any of you who have gone through the phase or practices of trying to do a Terraform state move, that can be problematic. And this really helps that because you could store this with your source control, so you kind of have that story of how resources went from A to B and so on through its entire life cycle. Then we get into another big area that was added as part of Terraform 1.3, and this is the optional object type attribute. So for those of you who have been around and using Terraform for a while, this is actually one of the highest upvoted issues that we've had on the GitHub repository. And this really allows a lot of flexibility when it comes to how you define complex object types within your variables. Going back to my former days as creating modules on a semi-regular basis, if I had a very specific module that I had to create, I'd create the variables that align to it, and then somebody would come along and say, hey, by the way, I also need to do this other thing. A lot of times I would end up having to say, oh, look, now we get to work with 2 modules instead of just 1. And this is an easy way to really change the way that you manage your modules to make them a little more extensible. Now we're going to transition over into our Terraform Cloud updates, because we have had some significant updates that Armand talked about this morning, and then Harold went into a little bit further as part of the infrastructure roadmap session. So first and foremost, we're going to start off with some of the health side of this. So at HashiCorp EU, we announced what's known as drift detection. This is basically a way that Terraform Cloud is going to look at your workspaces, check your state, verify it against your resources that are out there and having been provisioned, and say, has anything changed? and it does this as a regular interval. So that has actually gone from beta, and we're now in the general availability phase. However, one of the big things that's changed there is we've actually added a subsection to your workspaces known as health. Because drift is just kind of the first stage of whether or not your resources or your workspaces are actually healthy, which gets us into the next big announcement that was this morning, which is continuous validation. So continuous validation has also been added into that health subsection, and this is what builds on top of those pre and post conditions. So what it's going to go ahead and do is, as part of that process, automated process, it's going to read through the configuration. If there's a pre and post condition, it's going to run through that. It's going to analyze your state and the resources that have actually been provisioned and say, are we still in alignment? And if not, it's going to present that out through a notification that you configure, either the yellow warning sign that's in the UI, or a Teams message, or email, or a webhook. Then we get on to the compliance side. So there's been some significant improvements there. First and foremost, yes, we have heard the feedback. Not everybody has a deep love in their heart for Sentinel like some of us do. And so what we've done is we have announced the native OPA support for OPA within Terraform Cloud. So now it's a first-class citizen. You can literally type in rego policies within the Terraform Cloud console, or you can connect it out to your version control repository of choice, so that you can just basically import those automatically on a continuous basis to always have the most latest and greatest up-to-date options or policies within your environment as you're running through your Terraform workflows. Then again, on the compliance side, we have also made Sentinel policies a little easier to discover. So if you've noticed, hopefully you've seen some of the improvements that have been happening to the Terraform registry. We've been changing a lot of the way that the private registry works. We've been making updates and improvements to the way that you pull out some of the metrics and information from the Terraform registry. For those of you who may share and maintain modules or providers. And what we've done now is added a new object type to the Terraform registry in the form of Sentinel policies. So now this allows you to create Sentinel policies, share them out through the Terraform registry just as you would any other module or provider. So it really helps to, basic discoverability in terms of, using Sentinel within your environment. And then getting towards the tail end here of the slide so that we can get into the demos, the other big announcement this morning was no-code provisioning. So this is an enhancement to the way that modules are written, created, and added into the private registry to allow you to have literal checkbox. I want to deploy these resources. Terraform Cloud is going to go ahead, set up your workspace, and start the apply process. And then we'll see in the demo how we can then add in some of the guardrails to that process to really make this a whole lot more automated, and especially scale it out for those folks who may not want to, dabble within HCL or, get involved with the CDK TF side of things. And then lastly, we have some updates to the way that we integrate with third-party tooling as well. So here, at the time that I had to turn this deck in, pre-plan run tasks were being announced for beta. And this basically is a new way to go through and do security scans or other type of integrations and comparisons against your plan or your configuration. Because you scan your configuration, then the plan process runs, then post-plan run tasks, which is currently GA. And you can see some of our sponsors that are downstairs in the HashiCorp zone who have some fantastic integrations there. However, we have also now announced the beta of the pre-apply run tasks. So this is one of those situations where, if you want to integrate into, say, make sure a service is running before you actually run through the apply. Great use case for that. And it's been kind of interesting to see all of the feedback that we've had on run tasks, kind of how it's evolved throughout. All right, so that's a lot of slide time. So we are going to go ahead and transition into our demo environment here so that we can see some of these things live and in action. So the first thing that we're going to start off with here is a Terraform configuration that just creates a very simple web server that's out living in AWS. In this case, we're going to use both HCP Packer, so we're sourcing our AMI ID from HCP Packer, and then we're provisioning it in AWS. And we're going to go ahead and use the cloud backend here, cloud integration, so that we can use our local workflow and still communicate with Terraform Cloud to still run that remotely and still take care of our state management there. So here we already have our deployment going on here. And if we go out to our Terraform Cloud interface, this is the workspace that aligns with that. However, going back to our code, if we go back down and kind of analyze what's here, there's a lot of scrolling. There's a lot of lines that are going on here. And this is probably not something that your more basic user, or especially somebody who's new to Terraform, is going to be able to maintain. So what we want to do here is move this into a module, because that helps simplify a lot of the things that are going on here. So we're going to move into a different branch. So we can see the screen actually empties out because we're going from that 100 and some lines of code, and we're now down to about 43 because we've separated out all of the code of defining those resources for that web server and put that in a local module that's now off in my modules folder. Now this is what worked using a move block with Terraform 1.1. However, that's not really where it stops. You kind of want to build on top of that, because a majority of you are probably going to use this within your organization, and you want to share that throughout. You want to standardize on some things so that it's consistent throughout. So what we're going to do now is we're actually going to jump ahead a little bit. Actually, let's take a look at our move block here. So this is the sample for what it looks like to move resources from your root module and move them into your local module. And again, the benefit of this is that it's right there. You can add it to your source control. You can have it readily available to give you that kind of context in terms of how your resources have evolved, or your infrastructure has evolved through time. Now, if I were to go ahead and just run a Terraform plan, it's going to say that all of these things have moved. But for the sake of time, we're going to jump ahead and go directly into using a module that is sourced from our Terraform Cloud environment here from our private registry. So what we can see here is our source has been updated to be app.terraform.io, and we can also source versions. So this is also very helpful for those of you who maintain modules. You can also source different versions of the modules when you're working with these resources. So now if we go ahead and run our, we need to do a Terraform init real quick to actually download and make our module available. And then we can run our Terraform apply. So what's going to happen here is it's going to look at our environment, analyze what's out there, what's existing currently today, and then it's going to check with our module that it just downloaded and made available and see kind of what's going to line between the separate various resources there that it's determined and figured out. So as soon as it runs through, it's going to probably hit HCP Packer to verify and update our AMI to see what's changed there. And then it's running through the rest of our resources there. And now we get the output from that Terraform, at least the plan phase of that. So we can see that it's starting to say that AWS subnet.hashiapp has moved to the new location of our module.webserver.aws. So it's doing all of these things without actually impacting our environment. Because once we get down there to the very bottom where it says, plan, we're not adding anything, we're not changing anything, and we're, most importantly, not destroying anything. So anybody who might be using those resources are still going to be okay, and they're going to be unimpacted by us refactoring over to this module. So we're going to hit yes there just to make that change to our state file. So everything is now going to align to our module.webserver-aws module. And so it's going to make all of those updates to our state file, and now we're set, ready to roll with our environment. So next, what we want to do here is we're going to do something that hopefully none of you actually do, but we're going to start causing some drift. Because we want to see what the impact is of maybe somebody who has permissions that they shouldn't have, what that looks like in this environment. So we're going to go out to our AWS console here, and we're going to click around the UI. So here's our instance that was created. We're going to go ahead and manage, say, our tags, and say we're going to remove one of these tags. If you're doing a lot of things like reporting or anything along those lines, and a tag changes or moves or disappears, it's going to be fairly impactful. However, we're not done there making impacts to this environment because we really want to see how thorough drift detection actually is. So we're also going to make a modification to our security group, and this time we're going to delete our SSH rule. We'll see later that probably shouldn't have that rule in our security group whatsoever, but details, and we'll see the output from some of those security and compliance tooling later. Now at this point, we've caused some drift in our environment. So, if we rerun our Terraform plan, it's going to say, hey, your tags changed, your security groups have changed, and we need to update those things. But we also now want to trigger something within continuous validation. So what continuous validation is doing is it's set up to go out and read our HCP Packer environment. So here what we're doing is we have a couple of different sets of images that we're working with. First and foremost is our base image, which you can now see some of the objects that are new here if you're new to HCP Packer, specifically to our parents and children. This is one of the new announcements that was released this morning as a beta in terms of ancestry for your images. So if we click into like our base image, we now see the ancestry area, and we can see that there are 2 children who are dependent upon this image. So not only can we see which images are dependent upon them, but we can also see whether or not they're actually up to date. So it's really good from that side of awareness and being able to understand what's going on within your environment. Because back in my vSphere admin days, or if I really want to date myself, VI admin days, it was just a spreadsheet that I was using, and that's rather unfortunate if you ever take time off because, well, things change and people don't know where that spreadsheet is, and it's just not a great time. So in this case, on our web image here, we see that our parent is going to be that base image. But the really important part for our post condition that we wrote and continuous validation is the alignment to a channel. So we're calling out our production channel that's right here. And what we're going to do is actually change that. We're going to update this to a different iteration. So let's jump to version 9. So we're just going to go ahead and update that channel. We get a nice little message that said successfully updated the channel. And then now we can return back to our Terraform Cloud environment. We can hit our health subsection that's new as of drift detection going GA. And in our settings, we can enable it. This is something that you can enable it for all your workspaces, or I'll let you in on a little bit of a secret why I'm doing this way, because when you enable it for a workspace, it kicks off the check within about 5 minutes. So we're going to enable that, save it, and then we're going to let that kind of run off in the background and move on to our next section of the demo and get back to it. So next up, I'm going to kind of switch personas. Instead of being able to create and provision my own resources in this environment, now I'm somebody who may not know how to write Terraform or create code, or maybe I just don't even have access to the version control system. So therefore, I'm out there, creating, shadow IT type situations. Instead, what we can do is hop into our private registry here, which again, we've been making a bunch of updates here. So you can see that now you can source public providers within the private registry, meaning that instead of having to go to registry.terraform.io, you can do it directly within your organization, so that again, consistency is key in between all the different areas. But again, we're more interested in the module side of things. And here we can see a brand new filter that's here at the top for no code ready. So what we want to do is we're going to, again, deploy that simple web server within our environment. Down here, we have a couple different modules that are available for no-code provisioning, but this web server AWS module is the one that we're looking for. Here we see a module in very similar ways that every other module exists out there today. If you've created a module, shared it within either public registry or private registry, you can import and view the README, so we can see some of our prerequisites. Like this is in AWS, it's using Terraform, obviously, and it's running HCP Packer. You can also do some fun things like add in a gratuitous cat picture. But then it also provides you with the inputs, outputs, any dependencies, which in this case we do not have, and how many resources are going to be created. But again, the important part here is this purple button in the top right-hand corner that says Provision Workspace. So we're going to click on that button, and it's going to give us the variable editor. So this is something that if you've created a workspace within the UI, you probably have seen this before. If you haven't, this is new to you. So this is basically taking in our variable definitions and presenting it out in our UI here. So it's saying, we would like an instance count. We'll tell it 1. HCP Packer channel name, we'll do production. And then for HTTPS, this is actually set as a Boolean, so the UI knows enough to actually set this as a true or false option. So next up, we're going to hit, we have another new addition that's in here. We can also tell the difference between a number or a string when it comes to the more basic items when it comes to variable validation. So in this case, it's looking for a number, so we'll supply it with a number, and then we get back to our kind of more normal workspace settings where it's going to ask for a name. So we're going to give it HashiCorp, and we'll give it no code web server. Then we can give it a description, and then the other big change here is the apply method. So because this is a no-code provisioning workflow, what it's going to do is automatically hit the auto apply, meaning that basically we believe that this module that's being used and called on the back end has already been pre-approved. So there's no real reason to go ahead and check or wait, require an approval in between the plan and apply process. Now again, this is part of a beta process, so you can also provide us with a ton of feedback on why you think that is good or not so good. Then we hit our Create Workspace button down there at the bottom, and it's going to take us directly into our workspace. So this is just your standard workspace that you've probably seen, hopefully seen many times before. However, there are a couple caveats here. The first one is that giant disclaimer that's going right across the middle of the screen saying, hey, this is a no-code workspace or a no-code workflow workspace. And it also gives you a link out to say, hey, would you like to provide some feedback? Now, the other big thing is on the right-hand side there where it's calls out, it designates the module. So you kind of have an idea if you're, say, a Terraform Cloud administrator, if you're going into the environment, you know where these resources were provisioned from or where they were being sourced from. So you can go right down to the module as well as the version on top of that. Then looking a little further, we can see our latest run has also progressed further, but we want to be good stewards of our environment here. So we're going to add some tags here real quick. Actually, not that one. We would like to do HashiCorp. We're also using Packer, and then we are also using the AWS service. So now we have some tags, so we have some metadata to filter and sort by. We also want to do some other cleanup here, so we can add role-based access control to our environment through a team access configuration. Here, since we're deploying into AWS and we might have an AWS team involved, we can select that AWS team and then give it the appropriate permissions. You can do read, plan, write, admin, or custom. For this one, we're going to give it write. So now when we go back, still applying, still taking just a little bit of a second here. So let's check out our variables and see what's going on behind the scenes. So for our workspace variables, these are dependent upon the specific workspace itself. So we can see those variables that were in the variable editor. So we see our HTTPS, we see our HCP channel name, we see the instance count. And then below that, we get into the variable sets. Variable sets are a very nice way that you can apply different variables or sets of variables, if you will, across either multiple workspaces or all workspaces. In this case, the magic that's going on for part of this demo is that these are being applied to all workspaces, so it's picked up automatically so that we can talk to our AWS environment and we can talk to our HCP environment as well. All right, so now if we return back to our, there we go. So it looks like our run has completed. So we can see that our plan has gone through. It's created 9 different resources. And we should see all the information down there, including our outputs. Now this is always kind of a chance thing. Maybe it will already be provisioned, maybe it will not. And in this case, it is. So from our no-code provisioning workspace, we now see that, in this case, one of our developer advocates, Cole, is saying hello from our HCP Packer image. So that is something that is live and running. So now what we want to do is kind of take a step back and think about this from our administrative level. So now that we've given people the ability to go ahead and create their own resources, literally provision things like a web server within their environment, how do we make sure that they are following the guidelines of either the organization or other compliance standards that are going on out there? So what we're going to do now is apply some policies to this particular workspace. So we're going to jump into the settings side of our workspace here, and we're going to take a look at our policies. So what we have here is the ability to add policies directly into the UI of Terraform Cloud. In this case, again, this is where the update has happened, so you can now update or add OPA policies directly through the UI. If we click on that, it'll change some of this. It'll tell us that this is a beta feature, so heads up about that. There's a couple enforcement levels. If you've ever run Sentinel policies, you're probably familiar with how those work. And then there's the settings below. However, it's not fun to watch me type in Rego policies like that, so we'll jump into one that's pre-created. So in this case, we're looking for some EC2 instances to be either T3 micro through T3 medium. If my highlighter will work there. It's going to be an enforcement mode advisory because this is a live demo, so I don't want to break too many things. And then down here we get into the policy itself. So we can see what the package is. We can see the imports. So like in this case, we're looking at the plan JSON that Terraform Cloud has created in the prior step. Take a look at which actions. We can take a look at the types. And then there's some other information, but down here at the bottom is another really great use case that we'll be able to see here in just a second, where the rule has been defined, and this actually shows up in the UI as part of the run or the analysis of it. Then once you create the policy, you can create or apply that to a policy set. Those policy sets are then applied to workspaces. So let's jump over to our policy set. So in this case, that's what our top one is here. So we can see our EC2 allowed instance types is our policy, and then if we jump into our workspaces, we want to assign that to our no-code web server. So we'll add that to the workspace there. And then, because for the most part, you probably don't want to be adding your policies directly into the UI. I'm more of a fan of adding these in through your version control system of choice. So what we have here is a set of policies that I've already pre-created, exist out in GitHub in this case. And so we'll go ahead and apply these to our no-code workspace as well. Then, just for simplicity or consistency's sake, we're also going to take a look at some Sentinel policies that have already been created and been maintained. The last time these were run were June. Was the last time I created or updated these. We're going to go ahead and add these to them as well, just so that you can see the difference between how all of them kind of work together. All right, so now we have policies and some guardrails that have been attached to it. And here, if you'll notice, our health warning has already kicked off, so successful live demo for that portion of this as well. But now we also have some tooling within our environment. Because maybe you have some compliance checking, maybe you need some costing or analysis on that aspect, or maybe just impact to see what the output of your plan is going to create within your environment. So now we want to tie in some integrations to this workflow so that we have a better understanding from some tooling that we might already be using today. And we're going to use run tasks for that. So here on our run tasks, we have a couple run tasks that are already created and been made available. Infracost is one of them. That's a costing one so that we can see kind of how much our resources are going to cost within our environment. Sneak, which is a compliance checker. HCP Packer, which is going to run out to HCP Packer, look at it, say, is this image valid or has it been revoked? Anything along those lines, and return that back into our Terraform workflow. And then Spectral is a new one. So let's go ahead and add some of these in real quick. We'll notice that we can also configure this for a particular stage. Now for this case, infracost, it works on the output from the plan, so it's only going to work on the post-plan side of things. That's certainly something that will improve upon some of our betas exiting and going GA. Sneak can be applied at many different phases, but we're going to continue to use this as part of the post-plan phase. We're going to skip HCP Packer for this demo, and then Spectral, we're going to run that as a pre-plan run task because it's going to import the configuration file and give us some analysis based on that. So now what we're going to do is kick off a new run on our no-code workspace here. Now we have a couple different types of runs that we can also apply to our environment here. You can do your standard plan and apply that everybody knows and loves today. Maybe we need to do a refresh state. This is helpful for those situations where drift is involved. Or one of my more favorite ones here lately is plan only. This is a speculative plan, which means it's literally plan only. It's not going to impact your environment. However, the one big thing that's extremely nice is it allows you to choose the Terraform version. So, if you're working through your environment, if you might be looking at updating your Terraform version, this is a very easy way to know whether or not it's going to work without actually impacting the resources that are deployed within your environment. So it looks like Terraform 1.3.2 was probably actually released today because that wasn't available yesterday. So let's go ahead and keep it like that and just kick off our run. So if we jump over to our runs screen here, we should see that we have a run process that's triggering. So what's going to happen first is we're going to send our configuration file out to the Spectral service. As part of our pre-plan run task, where we can see that Spectral detected some things. 17 issues, as a matter of fact. So I should probably hand back my module author license or card, if you will, because 3 of those are actually errors, 2 warnings, and 12 informational items. If we jump out to Spectral, it'll also give us, we can use their UI, their dashboard, to take a look at what some of those items might be. Again, we have some security group issues. We can, if we change our zoom just a little bit, we can see, we can filter based on resource and kind of tell or have a little bit more contextual information about what's happening with this particular environment. However, let's jump back into our configuration or our workflow here. You see that our plan has completed, it's run out, it's seen that nothing's actually going to change. We have our post plan that is also configured and running out there. So we see that our monthly cost based on InfraCosts APIs is going to be $10.97 for this environment. For our sneak examination, it found no issues, and that's probably because our severity threshold is set entirely too high because this is a live demo. Then we get into our OPA side of things. So this is part of what's newly released today, and so this is what it's going to look like in your own environments. So it's going to start off with any failed policies that might have existed within your environment. In this case, we didn't have any, but we do have some advisory policies. So if we click on our AWS OPA policies, it'll actually produce that report or that rule that we had defined within our policies. So that was kind of the reason that I showed that off, because it gives you that bit of information directly in the UI. And then the same thing, we can also not just look at things within the plan, but we can also look at items that are going on within our Terraform, within our workspace. So like in this case, we're checking to see if our workspace is set to be auto apply. And so it's saying, hey, maybe you actually want to change this workspace apply method to be manual apply instead of auto instead. Now, based upon your workflow, that may or may not be what you want or what you need, but it does show you that it has some context about what's happening within the environment. And then we also have one particular policy that passed, and this is looking and validating some of our VPC network configuration. So then next we can drop into our Sentinel policy checks. So we have an output of some of our deploy time. That's a fun one that's basically enforcing a no deploy Fridays. And then we have some CIS validations that we could have sourced through, say, the Terraform registry. Some of these are widely available within that and really easy to adopt into your Sentinel policies. So at this point, we are ready to go check out our other workspace here. So if we jump into the workspace that we started off with and we refactored, we're going to notice off to the right-hand side here is the health portion has filled out and kind of given us some additional information about what's happening within this environment. So the top item there is drift, and then we also have checks, and checks aligns with continuous validation. We can also jump directly through into health, which takes us to our drift section, where we can see that there has been a modification of our AWS instance, where we can see that our tag has now been removed from that demo environment. So it successfully saw that, hey, I removed that demo tag, and that is drift. And we're going to see the same thing for our security group that's down here. We can see that that policy for port 22 has also been removed from our provisioned resources, but yet it exists in our state. From this point, you can either kick off a refresh-only plan, which is going to update your state file, or you can manually queue up a plan and apply what's going to fix those particular items. Then we jump over into the continuous validation area, and here we can see some updated information that our AWS instance, we have failed. So our post check failed, and it's telling us that we must use the latest available AMI and actually gives us that output there to us. So what I want to do here is take one step back, take a look at our code, and I'll show you what that post condition actually is. Jump down to the bottom here, and so here's our post condition that if I scroll up just a little bit, you can see this is living in our AWS instance resource. And then as part of that lives inside of the resource, AWS instance resource block is a lifecycle block. And this is where that post condition lives. So this is something that's available as part of the Terraform core side of things, but yet Terraform Cloud can take and build upon and kind of prove that or show that out within your workspace and kind of give you that additional context to say whether or not your workspace is healthy based on not just drift, but also these post or pre and post conditions. All right, so with that is our demo. So we're going to transition back into our slides for just a second because we have one more slide to hit that you are probably all very much aware of, and that is, try some of these features out. Again, a lot of these features are in a public beta and widely available for you to try out. And we have a lot of product managers who are actually here throughout this event, hanging out downstairs at the HashiCorp zone, who are looking for feedback. As a matter of fact, the continuous validation PM is here, as well as the Terraform core product manager is here as well. And so they're absolutely looking for feedback, looking for folks to try it out. Visit terraform.io for additional information, as well as learn guides that provide you with a walkthrough process of actually getting up and running with some of these features and capabilities within your own environment. And then, of course, hit up our GitHub repository. That's where the open source binary lives. That's where our issues live. And as always, appreciate everybody for reaching out through the repository, through the Discuss community, and really just being a fantastic community. And of course, thank you all for attending this session. It is very much appreciated. Thank you.